In a randomized controlled trial conducted with children suffering from viral croup, 46 children were treated with low humidity, while 46 other children were treated with high humidity. Researchers used the Eastleigh Croup score to assess the results after 1 hour. The low humidity group had a mean score of 0.98 with a standard deviation of 1.22, while the high humidity group had a mean score of 1.09 with a standard deviation of 1.11. Using alpha equaling 0.05, the significance level, test the claim that the two groups are from populations with the same mean. So since they're dealing with two different groups, we need to pick out the information within so it's easier to reference later. So we're dealing with sample means from two different groups and sample deviations from two different groups. So we need to write those out specifically off to the side. So we have x bar 1, which is the sample mean of the first group, which is the low humidity group, of 0.98, with a sample standard deviation of the first group being 1.22, and a total number of people in this group being 46. Now we also have the sample mean from the second group being 1.09, a standard deviation from the second group also being 1.11, and the total number of people in the second group being 46 as well. We also have our alpha, our significance level, being 0.05. So now that we have all that information off to the side, we can go and write out our hypothesis test. And so the claim is that the two groups are from populations with the same mean. So we have our null hypothesis and our alternative hypothesis. So we know we're dealing with means, mu. So null hypothesis should be mu1 equals mu2, because equality for the null is the standard. Now for the alternative, we go back to the claim. The claim is that the two groups are from populations with the same mean. So nothing about greater than or less than, which means the only thing we have left to use is not equal to. And so that is the alternative hypothesis. Now we're going to go in and use our calculator to do the hypothesis tests. So calculator is the easiest way to do it. So here's our calculator, and we are going to bring it up. And we're going to use hypothesis test, so stat tests. And since we're dealing with two samples and it's a test, we're going to use two sample t-tests because we do not have the population standard deviation. So enter, and we're going to enter in our information. So everything should be written, typed in as it is written off to the side, makes it easier. And then the alternative hypothesis is with the symbol that we use. So since it says not equal to, we're going to use the not equal to sign. No for pooled unless stated otherwise, and then calculate. And then it gives us the information we need, which just comes from T and P, our test statistic T, and the p-value P. So negative 0.452 and 0.6521 for P. So our t-stat, our test statistic, T equals negative 0.452, and just going to move the calculator out of the way, and then our p-value is equal to 0.6521. And so I'm going to use the p-value method to test the claim. So p compared to alpha. So 0.6521 is obviously greater than 0.05. So since it is greater than, we can say, since the p is high, we fail to reject the null. But when you fail to reject, or when you reject the null, you still need to type in your information in a sentence or so, your conclusion. So we're just going to do that here. So Since we failed to reject the null, that means we can't get rid of the equality part of the hypothesis test. So we can say, from the fact that we failed to reject a null, that there is not sufficient evidence to warrant rejection of the claim that the two groups are from populations with the same mean. Now, what does this mean? This just means that the results suggest that high humidity doesn't help treat group. Now, what if we were to do a confidence interval, 95% confidence interval, to estimate the difference between the mean Eastleigh group score of children treated with low humidity versus high humidity? So again, we want to use our calculator to do the work for us. So bring the calculator back up. And we are going to go to Stat, Tests. And before we did a 2-sample t-test, but since we're doing a confidence interval, we want a 2-sample t-int, int for interval. And then all the stats should already be typed in from what we did before. If it's not, just type it in. And the confidence level comes from how confident we want to be. We want to construct a 95% confidence interval, so our C level is 0.95. No for pooled, and then down to calculate. And here we are going to get the confidence interval of negative 0.5932 to 0.3732. So negative 0.5932 to 0.3732. Now, the confidence interval again is where we take the population means, mean 1 minus mean 2, to get these values. And you can see that we start off with a negative number and end with a positive number. So we go from negative to positive, which means somewhere in between these two numbers on the limits of this interval, we get 0. And the only way to get 0 is if the first mean and the second mean are equal. Because if they're equal and we subtract them, we will get 0. And that's very important in our determination of what's going on. So since it contains 0, that means at some point they are equal. So we can say in our conclusion that since the interval contains 0, we can say that there is no difference in the results of the treatments. The treatments being the low humidity and the high humidity. Which should say the same thing as our hypothesis test, that the results are from groups with the same mean. So there is no discernible difference between the two treatments. And that's all for this question.